Welcome to this lesson on functions and their types. In mathematics, functions are fundamental building blocks that establish relationships between sets of values. Today, we'll explore different types of functions, including one-one, onto, bijective, constant, and identity functions. Let's start with the definition of a function. A function f is a rule that assigns to each element x in a set A exactly one element f, x. In set B, set A is called the domain of the function, and set B is called the codomain. The range or image of the function is the set of all outputs f, x, for all x in the domain. The first type of function we'll discuss is the constant function. A constant function is a function that maps every element of the domain to the same fixed element in the codomain. For example, the function f, x, equals 5 for all x in the real numbers. Here's a visual representation of the constant function. Notice how every input maps to the same output value of 5. Next, we have the identity function. An identity function maps every element to itself. For example, the function f, x, equals x for all x in the real numbers. Here's a visual representation of the identity function. Notice that every input x is mapped to the same output value x. Now let's discuss one-one functions, also called injective functions. A function f is one-one or injective if distinct inputs always give distinct outputs. Mathematically, if f of x1 equals f of x2, then x1 must equal x2. Let's take an example. The function f, x, equals 2x plus 1 is a one-one function. Let's visualize this. In a one-one function, each element in the codomain is mapped to by, at most, one element from the domain. Next, we'll explore onto functions, also called surjective functions. A function f is onto or surjective if every element in the codomain has at least one pre-image in the domain. Mathematically, for every y in the codomain B, there exists at least one x in domain A such that f of x equals y. An example of an onto function is f x equals x cubed from real numbers to real numbers. Let's visualize this. In an onto function, every element in the codomain is mapped to by at least one element from the domain. Now, let's talk about bijective functions. A function is bijective if it is both one-one injective and onto surjective. This means there's a perfect pairing between domain and codomain elements. A simple example of a bijective function is f(x) equals 3x minus 2. Let's visualize a bijective function. Notice that every element in the codomain has exactly one pre-image in the domain. Let's summarize what we've learned about different types of functions. A constant function maps all inputs to a single output. An identity function maps every input to itself. A one-one or injective function ensures distinct inputs give distinct outputs. An onto or surjective function ensures every element in the codomain has at least one pre-image in the domain. And finally, a bijective function is both injective and surjective, creating a perfect one-to-one correspondence between the domain and codomain. Understanding these function types is essential for higher-level mathematics, particularly in fields like calculus, abstract algebra, and analysis. Thanks for watching.